Welcome to 3.3, sorry. And let's get started. Find the value of x that makes your reasoning true about the angles m and n parallel to each other. Okay, so in order for m and n to be parallel to each other, you have to set 3x equal to 120 because of corresponding angles. Okay, they are corresponding, and we're finding the value of x that makes it work so that those angles are equal. And if they are equal, then the two lines are parallel. So you divide off the 3, x equals 40. So x has to be 40 for those lines to be parallel. All right, number 3, that was number 1. Number 3, same thing. Why do we know that these two lines are parallel? 3x minus 15 and 150 are consecutive interior angles. All right, so consecutive means supplementary. So we add them together and they equal 180. So the value of x that makes this equal to 180 would make the two lines parallel. So negative 15 and 50 would be 135. We subtract the 135 and we get 3x equals 45 and divide off the 3, x is 15. And if x is 15, then m and n are parallel. Number 5, again, x and 2x are consecutive. So you add them together and set them equal to 180, and that'll tell you what x has to be for m and n to be parallel. So 3x equals 180. Divide off the 3, x is 60. And there are your answers, which is what we got. All right, let's move on. Okay, state whether there's enough information to prove that the two lines m and n are parallel. So looking at 11, we see these two angles here, which are alternate interior angles. Okay, so the alternate interior angles converse theorem says that if those two angles are equal, then m is parallel to n. Okay, so yes, there is enough information. Okay, 13. These two pieces of information here, we don't have, they are alternate, but they're not matching up in any way. And unless those two angles are 90 degrees, we can't prove anything else. So no, there's not enough information there. And there you have your answers for 11 and 13. Let's take a look at 15 here. There is nothing on these sides for m and n to be parallel, or even s and r to be parallel. All we have is vertical angles at one intersection. Remember, you have to go from one intersection to another. So number 15 is no, not enough information. All right, moving on. All right, 17. Describe what they did wrong here. Let's see what they say. A is parallel to B by the vertical angles congruence theorem. Okay, so vertical angles are only at the same intersection. So right off the bat, this is incorrect. Okay, vertical angles doesn't prove that two lines are parallel. So the only thing you can say here is that they're not parallel. There's not enough information. So there's a good explanation. X and Y would have to be equal for those lines to be parallel. Okay, 1921. Are A, C, and D, F parallel? Explain your reasoning. So now we have to see if we can figure this out. Okay, so let's go through and kind of look at what we have here. Angle B in number 19 is 123 degrees. Do we know that? We don't know that. If they're parallel, then we can say that those are parallel. They're parallel. So we don't know that they're parallel. It doesn't make any sense. So you can't say that angle B is 123 degrees unless those two lines are parallel. So there's not enough information here unless you can say, and again, this is why we're doing this, vertical angles, we know that's 57 degrees, and we know the other vertical angle, this is 123. Okay, so now we have consecutive interior angles there. So is 57 plus 123 equal to 180? So if it is, then yes, by the consecutive interior angles, consecutive interior angles converse theorem. So is that true? Well, yeah, 57 and 123 is 180. So yes, by the consecutive interiors converse theorem, the two lines are parallel. So you do have to do a little work. All right, now let's move on. You have 62 and 62, but there is nothing here. We don't have any information here to show us what those degrees are. This consecutive interior angles, this would have to be 118 degrees in order for them to be parallel. So we don't have enough information there. And there you see their answers from the book. So pause it and take a look at them. Okay, each rung of the ladder is parallel to the rung above it. So it's telling us that each one of these rung is the step part. So each of these are parallel to each other. Now it says explain why the top rung is parallel to the bottom rung. Okay, well, by corresponding angles, angle theorem. The corresponding angles are congruent, then they're parallel. We know they're both parallel, and so by corresponding angles all the way up, those are all parallel. And so here you can see by the transitive property, one is to the other, as to the other, to the other, to the other, all the way up to the top. Okay, let's move on. Number 26, one way to build stairs is to attach triangular blocks to an angled support as shown. The sides of the angled support are parallel if the support makes a 32 degree angle with the floor. What must angle 1 be? So the top of the step will be parallel to the floor. Okay, so we have parallel lines here. So if this is 32 degrees, we have angle 2 to be 32 degrees because we have these parallel lines. Those are corresponding angles. All right, so angle 2 is 32 degrees by corresponding angles theorem. Okay, and if that's 32, we look at all of this. Angle 1 is here, angle 1 is there, and there. Okay, so now what you have to look at is you have the step and the floor are parallel, and the angle 1 and the angle 2 are alternate interior angles. So now we have the measure of angle 1 equals the measure of angle 2, so the measure of angle 1 is 32 degrees. And there you have the answer for number 26. Okay, which rays are parallel? So for rays to be parallel, they're going to have the same angles between everything. So none of these four have the same angles. So you would not say that HD is parallel to EB because they're facing a different direction from a stationary line. So the stationary line is FG. All right, so let's get all of that off there. That means we need to find these two angles. So you have 180 degrees, which is a straight line. So you're going to take 180 and you subtract the 61 and the 59, and that'll give you 60 degrees. So this little angle is 60. And then the same thing over here. This is 180 degrees, so you subtract 180 minus the 58 minus the 62, and you get 60 degrees. So that's 60 degrees, okay? So here's the thing. If this is 60 degrees and that's 60 degrees from the stationary line, then they're heading the same direction. So AE is parallel to HC, okay? So EA, the ray EA, is parallel to HC. That's how you would say it. Okay, let's move on. Okay, so let's write a proof to show that M is parallel to N. All right, so really quickly, let's draw two-column proof. And let's write down our givens. Measure of angle 1 equals 115. Measure of angle 2 is 65 degrees. So if you set up an equation, the measure of angle 1 plus the measure of angle 2, now we're not adding two angles together. Okay, we're setting up how you are going to add the two together, where you can get the 15 and the 65 to be added together. So you can't just set it up as like the measure of angle 1 plus the measure of angle 2 equals 115 plus 65. You have to set it up so that you are able to substitute things together, replace things. So we're going to substitute here in a second to show that you're just adding the 115 and the 65 together. So how we set that up is you add angle 1 and angle 2 and set that equal to the addition of the same thing. That's the reflexive property. You have to set up something that you can do something with. You just can't take the first line here and add the two together. There isn't a property for that yet. So once you have set up the equation, then you can substitute those values in and say what you were wanting to say. That the measure of angle 1 and the measure of angle 2 is equal to 115 plus 65. All right, so that's substitution. But you had to set up the equation first. You had to give yourself something to do something with. Okay, and then, so the measure of angle 1 plus the measure of angle 2 is equal to 180. That's just simplifying. You're not adding. If you say adding, that means you're adding something to both sides of the equal sign. All right, so you're just simplifying there, combining like terms. And now, the measure of angle 1 plus the measure of angle 2 are supplementary, okay? Or the angle 1 and angle 2 are supplementary, okay? And how do we know they're supplementary? Supplementary, the definition of supplementary angles, okay? That means they add up to 180 degrees. And if they're supplementary, then M is parallel to N because of the consecutive angles converse theorem. You showed that they were supplementary. That's what consecutive angles are. They're supplementary. And there you have the conclusion from the book. Let's go on to the last problem. Okay, another two-column proof here. What is our given? That's going to be angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So we're trying to prove that these two lines are parallel, so I'm going to draw this a little bit bigger. So angle 1 and angle 2 are congruent, and then angle 3 and angle 4 are congruent. So now you can say that angle 3 is congruent to angle 2. Those are vertical angles. Okay, vertical angles theorem. And if that's the case, you have a transitive property here. Angle 1 is to angle 2, is angle 2 is to angle 3, so angle 1 is congruent to angle 3, transitive property. Okay, and then if angle 1 is to angle 3 and angle 3 is to angle 4, then you can say angle 1 is congruent to angle 4, again, transitive property. And if angle 1 and angle 4 are congruent, these two right here, if these two are congruent, and we're trying to prove that these two are parallel, you have transversal, you have alternate interior angles. And since we're trying to prove they're parallel, it's the converse. So if angle 1 and angle 4 are congruent to each other, then you have AB is parallel to CD by the alternate interior angles converse theorem. So a couple tough proofs. Hopefully you got something out of each of those.